Today we are going to discuss regarding the S curve hydrograph, how it is obtained, then how the numerical examples can be solved, and how the curve is obtained. So all these things we are going to study regarding the S hydrograph, S curve hydrograph, or simply S curve in this session. S hydrograph or S curve is a hydrograph that is produced by a continuous effective rainfall at a constant rate for indefinite period. It is a continuous rising curve in the form of letter S till equilibrium is reached. Construction of S hydrograph. The method of simple superposition is applicable only when other duration is integral multiple of the available duration of the unit hydrograph. However, many a times it becomes necessary to generate a unit hydrograph of other duration which is not integral multiple of the available duration. In such cases, it becomes necessary to evolve such a general method based on the principle of superposition. Such a method has been evolved by hydrologists, which is called S hydrograph method. A S hydrograph is nothing but a hydrograph generated by a continuous effective rainfall occurring at a uniform rate for a for an indefinite period. It is called S hydrograph because the shape of the hydrograph comes out like alphabet S, though slightly deformed. Now, in this type, S curve approach should be used for the calculation. Now, again, we will discuss on this S curve of S hydrograph. A S hydrograph is nothing but a hydrograph generated by continuous effective rainfall occurring at an uniform rate for an indefinite period. This is the first point we have to remember when you are discussing regarding the S curve hydrograph. Then again the point that we have discussed that one more time it is necessary to elaborate. It is called S hydrograph because the shape of hydrograph comes out like alphabet S, though slightly deformed. Now the figure that we are going to show, that is a typical S curve hydrograph or S hydrograph. It can be derived by summation of the ordinates of an infinite series of the unit hydrographs of same unit duration spaced at same unit duration apart, and hence the name summation hydrograph. So as we are going to sum up the various rainfall, so it is called as a summation hydrograph. It is a curve which rises continuously in the form or shape of the letter S till constant discharge or the equilibrium is reached. So these 4 points are necessary to understand. So very simple that on this y-axis what is we have plotted discharge in meter cube per second. On x-axis we have plotted time in hours, and how it is a general hydrograph, okay, which is like this. We are plotting the ordinates there as a in terms of discharge, okay, this O1, O2, O3, O4, O5, O6, and we are getting the hydrograph like this, a normal hydrograph. But when we are going summing up this every rainfall, as initially the O1 is there, okay, then next time the O1 plus O2, initially O1 is plotted here, you can see about this O2, then next O1 plus O2, addition of that, here again you are plotting there as a O1 plus O2 plus O3, so addition of this right? So total will be for this 4. So this particular curve you are going to get there as a S curve. This you are going to get there as a S curve. Okay. So please remember like that. Okay. The discharge of S curve at the time of equilibrium, where A is equal to area of the catchment in the hectares, I is the constant rate of effective rainfall in centimeter per hour. If A is taken in square kilometer, then the equation that we can get, that the ordinates of the S curve can be plotted by using the equation St is equal to Ut plus S into bracket T minus D, where St is the required ordinate of S curve hydrograph at time duration T. Okay, what is Ut? Ordinate of the given unit hydrograph at time duration T. Okay, so that we have seen. And what is T? Required duration in hour. D is the given duration of the unit hydrograph. So S into bracket T minus D is the S curve ordinate of preceding interval. Okay, so that's we have seen. We can see this is the existing, or you can say the present interval is there, and preceding is the O1. Okay, similarly O3 is there. Earlier ordinate you can find O1 plus O2. Okay, so same is expressed here there as a S T minus D. Now a simple example, that derive the S curve ordinates from the given unit hydrograph. Ordinate of the hour unit hydrograph is given, column 1 and column 2. So these are the time in hours are given: 0, 4, 8, 12, 16, 20, 24, 28. Okay, likewise. And corresponding ordinates of the 4-hour unit hydrographs are given: 0, 10, 30, 25, 18, 10, 5, 0. Okay, so ordinates of the S curve, that St is equal to Ut plus S into T minus D. For the S0 at T is equal to 0, Ut is equal to 0, St minus D is equal to 0, thus S not is equal to 0. So duration is 4 hours, that is given duration of unit hydrograph. Then S4 at the S4 at T is equal to 4, Ut is equal to 10 meter cube per second, St minus D, S4 minus 4, that is S naught is equal to 0. Okay, this S4 is equal to 10 plus 0 is equal to 10 meter cube per second. Okay, so that we have seen earlier as well. So S8 is equal to, again take 4 hours interval, at T is equal to 8, Ut is equal to 30. Okay, so this value. So St minus D, that S8 minus 4 is equal to S4 is equal to 10. So S4 is equal to 30 plus 10 is equal to 40 meter cube per second. Okay, for S12 again 4 hours duration, at T is equal to 12, Ut is equal to 25, S is T minus D is equal to S into 12 minus 4. Okay, so S8 is equal to 40. So this S4 is equal to 25 plus 40 is equal to 65 meter cube. So this continuously we can calculate. Okay, and this table can be plotted. You can see here. This is the table which was given: time in hours 0, 4, 8, 12, 16, 20, 24, 28. Okay, ordinates of the 4-hour unit hydrograph, it is given 0, 10, 30, 25, 18, 10, 5, 0. This is simple addition and subtraction is there. Now S curve addition, how we are getting? Initially here it is a 0 at this position. Okay, And how we are going to calculate this? 0 plus 10, you are going to get 10 here on this side, column 2 plus column 3. Okay, so initial ordinates of this particular S4 curve ordinate, you will here will be 0. Okay, then next is, if the 10 is there, so you can bring 10 here. So 10 plus 30, what you are going to get? 40. So that's why you can see here. So initially it is 0. Okay, then 10, then 40 comes here. Okay, that's why you are going to getting here 40. Then 40 again bringing it to the next point. So 25 plus 40, it is 65. Okay, 25 plus 40 is equal to 65 meter cube per second. And similarly you are going to calculate this. Okay, 0, 10, 40, 65, 83, 93, 98, 98, and you can plot it on the, so you will get the curve like this. Okay, so very simple. Now again, one more thing we can discuss. Determine the 12-hour unit hydrograph from given 4-hour unit hydrograph by using the S-curve method. Here we have to remember the 12-hour unit hydrograph we have to obtain. So in this case, D given duration is 4 hours, but T required duration is 12 hours. Now I will read the step 1. Only remember that in the last here, even though I am reading all these steps, so we will understand better here in this table how we can going to calculate this, how we are going to calculate this here. Okay, the same steps are there. So here everything is mentioned, but I will read the steps here so that will be understood properly. What is step 1? Draw two columns next to the given unit hydrograph, that is column 3 and 4. Okay, these two columns are filled consecutively as follows. So you can see these are the given figures, okay, of the 4-hour unit hydrograph, and column 3 and 4. Okay, so as we have seen that the next to the it is given as a 0, and the column S curve ordinate you are going to plotting it as a 0 here. Initial point will be 0. So this 20 plus 0, you are going to get here 20, and again you are bringing the 20 here. So 18 plus 20 is 100. So this is continuously obtained up to the last point. Okay, so here actually it is not necessary to read all the steps, but for your understanding I will read all this. So initially mark dash in the first rows up to preceding interval of capital D hours of third column. In this case D is equal to 4 hours, thus mark dash up to T is equal to 0 only. Okay, so you can see here it is mentioned here also. Okay, and this dash also. So please remember. Okay, now make the addition of column 2 and 3, column 3, and write down in the column 4. Okay, addition of this column 2 and 3, which is written here. Addition of every this column 2 and 3, which is written here. Okay, then write the result of result as the next row in column 3 as shown by the arrow. Again make the addition of column 2 and 3, write in the column 4 that just I have told. Then again write up the result at the next column 3 shown as the arrow. Okay, repeatedly. At time t hour, drag the last ordinate from the column 4 in column 3, 20 as shown in by arrow. Now do the addition of 80 plus 20 is equal to 100 and write on the column 4. Okay, here 18 plus 20, there is 100 written in the column 4. Okay, continue this operation till end of the column 3 and 4. Okay, this column and 3 and 4 which is obtained from this, So we are carrying out totally here up to end. In column 4, we get the S curve ordinate, which are nothing but the running summation of the flow. So what we are getting? We are getting the summation here simply. Okay. So it is at, for example, 694 plus 5. We are going to get 699. 699 plus 0, 699. So likewise, up to your end point, you are going to get. Right. Then now lag this S curve ordinates by T hour shown in the column 5. Now in this case T is equal to 12 hour. Now note that always lag your S curve ordinate by that duration for which you are going to derive unit hydrograph. For example, if you are going to plot 8-hour unit hydrograph from given 24 unit hydrograph, then in the step 3 lag your S curve ordinates by 8 hour and vice versa. Okay. Now the step 4, now deduct that lagged column from S curve ordinates, that is column 4 minus column 5 is equal to column 6. Okay, you can see here. Okay, column 4 minus column 6 is equal to column 6. Column 4 minus column 6, column 5 is column 6. Okay, 0, 20, 100, 230 minus 0, 230, 280 minus 20, 360. Okay, 510 minus 100, 410, 600 minus 230, 370. That's all up to end point. Okay. Now, this is necessary because we have summed values which should be converted into single flow value. Okay, this will give a, okay, uh, DRH of a T by D in centimeter. Okay, and this value in this case T by D is equal to 12 divided by 4 is equal to 3 centimeter. 3 centimeter. Okay, so you can see here. Okay, so that will have to 12 divided by 4. Okay, which is a 3 centimeter. So every time now here up to find out this last column 7. So column 6, value of the column 6 is divided by the 12 divided by 4, because we are deriving it from the 12 to the 4, or can say 4 to the 12 likewise. Okay, so the column 6, the DRH of T by D is equal to 20 divided by 4, 3 centimeter. Okay, then this is the last step in which we divide the last column by ratio of the T by D, that is T by D is equal to 12 by 4, 3 centimeter, for getting the required 12-hour unit hydrograph. Okay, so you are going to get here these values. Only if you plot here, you will get the hydrograph for the 12-hour ordinates. Okay, so simple examples are there which can be obtained from the given data. In these problems, actually, when you are dealing with uh, the problems, especially with the rainfall, then runoff and the infiltration, all this. So statistical data which is given more, but it is a simply a statistics by which you can work out this value. Okay, so likewise, similarly you can obtain the data for the various duration, and the S curve hydrograph can be obtained. So important thing is that uh, instead of remembering the formulation, only if you remember the procedure, how the columns are plotted, how the value is obtained, and initially which uh, values will have to keep there as a dash. Okay, so other things you will, rest things you will get very easily. Okay, so thank you very much for joining today's session.